So today we are going to discuss Coulomb's law. So the statement I have already written here, the electrostatic force of attraction or repulsion acting between two stationary point charges is directly proportional to the product of the charges and inversely proportional to the square of distance between them. Coulomb's law is very important because the chapter electrostatics starts from here only, and you already know that the two like charges repel each other and two unlike charges attract each other, but this Coulomb's law gives you the amount of force acting between two charges. That means the magnitude of the force acting between two charges. So the one major point to notice here is that line I have underlined also, these two stationary point charges. So this law is applicable for stationary point charges only. So if the charges are not point charges, this law will not be applicable. So this is important to notice here. So let's elaborate this law more. So suppose you have two point charges q1 and q2, and what do you mean by point charges? Point charges means the size of the charges should be very small as compared to the distance between the charges. So suppose these are two spherical charges. Suppose the diameter of the first charge is something, diameter of the second charge is something, but that diameter should be very small as compared to this distance r. Only then you will call these charges as point charges, and then Coulomb's law will be applied on these charges. So if the charges are like charges, they will repel by a certain amount of force. If the charges are unlike charges, they will attract by certain amount of force. But in both cases, the force magnitude according to Coulomb's law, that is directly proportional to the product of the charges divided by square of distance between them. That you can read from the statement. Electrostatic force of attraction repulsion acting between two stationary point charges is directly proportional to the product of the charges. So it is proportional to q1 into q2 product, and inversely proportional to the square of distance, so inversely proportional to the r square. So this is the Coulomb's law, and Coulomb's law doesn't tell much about this proportionality constant, but it says that the proportionality constant, the proportionality constant depends on the medium. Which medium? The medium in which the charges are kept. So we can consider two different cases. Let's take case 1. Case 1, when charges are kept in air or vacuum. So when the charges are kept in air or vacuum, then the electrostatic force acting between two charges is maximum, and the proportionality constant you write as 1 over 4 pi epsilon naught q1 q2 divided by r square. And why did I say the force is maximum? Two charges repel or attract each other with a maximum magnitude of force when they are kept in air or vacuum. In any other medium, the force will get reduced. So here this proportionality constant I have written 1 over 4 pi epsilon naught. So let's see it more. So 1 upon 4 pi epsilon naught, its value, total value is 9 into 10 raised to the power 9. If you want to be precise, it is 8.99 into 10 to the power 9, and unit will be Newton meter square per Coulomb square. And specifically, if you want to write epsilon naught, then this epsilon naught is known as permittivity of free space or vacuum, and its value is 8.85 into 10 raised to the power minus 12, 10 raised to the power minus 12, and unit will be thus reciprocal of the previous unit 1 upon 4 pi epsilon naught. So it will be Coulomb square per Newton per meter square. Okay, so this epsilon naught is permittivity of free space or vacuum. So this is the maximum amount of force acting between two charges when they are kept in air or vacuum. Now let's discuss second case, case 2. When the charges are kept in any other medium. So in any other medium, as I told you, the force will get smaller as compared to the force in vacuum or air. So suppose I want to write the new expression for force, suppose that is F prime, then the original force was in air or vacuum, that was 1 upon 4 pi epsilon naught q1 into q2 divided by r square. But now the force will be reduced by a certain factor, and that factor we call capital K, and this capital K is known as a characteristic of the medium in which the charges are kept. So this capital K is called dielectric constant, or you also call it relative permittivity of the medium. And what is the value of this K? So obviously, as I said, F prime will always be smaller than F, so this capital K should always be greater than 1. Only then F prime will be smaller than F. So that means value of capital K can be anything between 1 to infinite, and this is 1 for air or vacuum, and this is infinite for metals, and for any other medium it will be between 1 and infinite. So when it is air or vacuum, you put K equal to 1, then you get just the previous law, this previous expression we have written, F equals 1 upon 4 pi epsilon naught q1 q2 upon r square for air or vacuum. And if you put infinite here, then force will become 0. So what does that mean? If two charges are kept in metal, then they will not apply any attraction or repulsion force on each other. And in any other medium, value of K will be greater than 1 and smaller than infinite. So definitely the force F prime is going to be smaller than capital F. So that's all I wanted to discuss with you people. So thank you very much.